So, welcome back to All This Math. This is Professor Parker. Today we're going to do some multiplication. And this is kind of one of those, quote unquote, new math concepts, right? We're going to get into. Before we get into that, check out who I got on my t-shirt. Today I got my France Fanon t-shirt on. All right. Definitely go do some research on France Fanon, F-R-A-N-T-Z, F-A-N-O-N. If you're not familiar with France Fanon, or if you're already familiar with France Fanon, you know, let this motivate you to go pick up one of his books. Hold that thought. Here we go. Probably his most famous, Wretched of the Earth. The Black Panther Party read this book, right? When they first started the Black Panther Party, Huey Newton and Bobby Seale had brothers and sisters reading this. Also, another famous one, Black Skin, White Masks, very relevant today. Also, we have Toward the African Revolution. Well, actually, I think all of his books are relevant. And last but not least, A Dying Colonialism. I believe these are all four of the books that he authored. If he authored more than these, forgive me. They're obviously not in my collection. They need to be. So let me know. Drop a comment if France Fanon actually authored more than just these four books. All right, but Fanon, a little bit about him. He was a Pan-Africanist, revolutionary, a psychiatrist, studied in France, and then, well, born in Martinique in the Caribbean, right? He was a Caribbean brother. Born in Martinique, then went to school in France, studied, became a psychiatrist, and then relocated to Algeria, which at the time was a French colony. And instead of, after observing the situation, instead of, you know, being neo-colonial and fighting alongside the French, he realized that he needed to be on the side of the people, right? Also, while, you know, all this struggle was going on, this is where he, you know, made a lot of his observations that led to these books that he authored. All right, so definitely check out France Fanon. The brother died young. He died young. He was a problem. He was a problem for the U.S. nation, other European imperialist nations, you know, because he was really trying to help and wake up the people and be anti-colonial. He was an anti-colonial struggler. So check him out. All right, now, multiplication tricks. Now, what we're gonna do with these, well, let me say this. I came up with the idea to do a video about this because I was in a tutoring session yesterday, and we were just running through in the beginning of our session. In the beginning of a lot of my sessions, I like to just have students run through multiplication facts, just as a practice, like a warm-up, right? So I'm tutoring this young brother, and he's got a poster in his room, and I recommend this to all parents as well. Any parents watching this, put up a poster of a multiplication table in your child's room so they can always see it, like every single day. Like whenever they come in their room, they see it. So that's a way for them to organically just practice their multiplication facts, right? Because the poster's up there in their room anyway, right? But the poster he has only goes up to 10 times 10, right? A lot of multiplication tables go up to 12 times 12. So he didn't have none of the 11 facts. He didn't have none of the 12 facts. His largest number was 100. It went from 1 times 1 up to 10 times 10. So I was like, all right, well, you know, let me show you this. Let me show you another way to still figure out what the solution to the equation 3 times 12 is, right? If we understand what's really happening when we multiply, we're just doing repeated addition, right? When we do 3 times 12, if we invert the words in that statement, right, instead of saying 3 times 12, we could think of it as 3 12 times. So 3 times 12 is the same thing as 3 12 times, meaning we add 3 12 times, like 3 plus 3 plus 3 plus 3 plus 3. That's why in actuality, multiplication is actually a gift, because multiplication is really a shortcut. So instead of you having to do 3 plus 3 plus 3 plus 3, you can just do 3 times 12. And if you memorize your multiplication facts, you'll know that that's 36, right? But let me show you how I showed him how to do it, right? He knows that 3 times 10, I said, well, tell me what 3 times 10 is, right? 3 times 10 is 30. So then after that, you're really just adding 2 more 3s. So this looks like this. One way to look at this is like 3 times 10 plus another 3 and another 3. Because in that 12, right? Think about what 12 is made up of. 12 is made up of 10 plus 1 plus 1. Now you might be saying, but that's a 3 and that's a 3. We're talking about how many 3s? How many 3s, right? This is how many 3s? 12. So altogether we got 10 of them right here. That's represented by this 10. And then we got 1 and 1 for a total of 12. So we can do this type of math. We can expand this, change this to 3 times 10, which gives us 30. And then we got 30 plus 3 plus 3. So 30 plus 3 is 33, and 33 plus 3 is 36, right? So that's a way to figure it out, right? And it's good to know these different methods for how to figure stuff out, because that's really what math is about. It's about problem solving and being able to figure stuff out, even if you don't have it memorized or you don't know it off the top of your head, right? So, and also we deal with happy numbers, right? I call them happy numbers. A lot of people call them happy numbers or friendly numbers. I call them happy numbers because then we get to talk about ancient Kemet. Because in ancient Kemet, there was the Nile River. I mean, the Nile River is still there today in modern day Egypt, but it was known as the Happy River, H-A-P-I, right? So we call these happy numbers because they end in 0, and it makes us happy because it makes the math easier, right? And then we can think about the Happy River. We can think about ancient Kemet. That's a good little segue into that. If you're a teacher and you want to, like, you know, talk about math and history at the same time, like a hystematics approach, right? You can do that, right? So this is another way to do 3 times 12. But also let me break it down another way, because again, this gets into like what people call the new math that frustrates people. But what we should realize is that it's really helpful to us, right? So your child might have came home and started talking about number bonds. You might be like, oh, 30 years ago when I was in school, we ain't do number bonds, right? We just had to memorize all the addition facts, all the subtraction facts, and all that. And that's cool. I had to do the same thing. But think about it like this, right? If I wrote 3 times 12 over again, right? And I did a number bond for 12, because 12 is the larger number out of the two. And I break 12 down into 10 and 2, right? That's a number bond right there, right? 12 is broken down into 10 plus 2. And I do 3 times each of these numbers. So I could think of it in terms of, right here, distributive property, distributive property. Another way to do this, right, is 3 times 10 plus 2, right? So what distributive property means is the number that's outside is going to get multiplied by each of the numbers inside the parentheses. Distributive property means that the number that's outside, this 3, is going to get multiplied by each of the numbers inside the parentheses. So 3 times 10 is going to be 30. And then 3 times 2 is going to be 6. And you add them because there was a plus sign right here. So you bring the plus sign over. So then you got 36. So either way, we get 36, right? Now we can do the same thing with 9 times 15. 9 times 15, most people not going to know what 9 times 15 is off the top of their head, right? I don't even know what 9 times 15 is off the top of my head. I can figure it out though, but I don't know it. I don't have it memorized, right? That's something that I still need to work on, right? So 9 times 15, let's do this. Let's do a number bond with 9 times 15. So let's say we got 9 times 15. We break 15 down because that's the bigger number. We pick a happy number. Think, you know, Nile River, ancient Kemet, happy, right? Happy, right? A happy number. Happy numbers end in 0. So we got 10 and we got 5. Now, why is it 10 and 5? Because 10 plus 5 equals 15. And I want one of my numbers to end in 0. Because now you don't have to use that. I mean, you could have did 9 and 6. Because all we're really trying to do is break these numbers down so that we can have basically 2 multiplication problems. And then we add the products together. We add the products together. So we could have broke this down into 9 and 6, right? And then did 9 times 9 and 9 times 6 and then added them together. I tend to like to, you know, go with the happy number though. That's just my thing, right? You don't have to do it that way, all right? And that's the beauty of math, right? Because there is more than one way to do any math problem, all right? And that's a beautiful thing, right? We should embrace that more. So we got 9, and then we got distributive property, 10 plus 5. 9 times the quantity, and this is called a quantity. Whenever you have an expression written inside parentheses, it's called a quantity, all right? So we got 9 times the quantity of 10 plus 5. So that means I'm going to do 9 times 10. And if I know that 9 times 1 is 9, then 9 times 10 must be 9 with a 0 attached to it. So that's going to be 90, right? And then 9 times 5 is going to be 45. You got to know some multiplication facts, though, in order to do this. So then 90 plus 45, right? I could break this down into 90 plus 40, which is 130. And then the 130 plus 5 gives me 135. So even if you don't know off the top of your head what 9 times 15 is, you can figure it out by using a number bond and breaking the bigger number down. I'm about to do the same thing with 8 times 17. So watch this, right? So 8 times 17, matter of fact, I'm going to do it over here. I'm going to do it 11 times 16 right here. So 8 times 17, we're going to have 8. Matter of fact, hold up. Watch this. You switch colors. Got too much black ink over here. So 8 times 17, let's do 8 times 17, right? Now, 17 is the bigger number, so I'm going to break the 17 down, right? So the 17, I'm going to break it into a happy number, 10 and 7. Like I said, that's what I like to do. I like to use a happy number. You don't got to do that. You could break 17 down into 9 and 8. You could break it down into 11 and 6, whatever you want to do, right? But now this becomes 8 times the quantity of 10 plus 7, right? Then I distribute, get an 8 to the 10. Boom. That's going to be 80 because 8 times 10 is 80. Then do it again, 8 times 7. Boom. What's 8 times 7? 56. You got to know your multiplication facts, right? Some of your multiplication facts, even if you don't know what 8 times 17 is, you got to know what 8 times 7 is. That's mandatory. You got to know that. All right, and then we add these two products together. We add the two products together. So we do 80 plus 50. If I know that 8 plus 5 is 13, then I know that 80 plus 50 is 130. Again, if I know that 8 plus 5 is 13, see how math just builds on previous and prior knowledge, right? If you learn your addition facts, then when it comes time to do multiplication, you might need to add 2-digit numbers, right? If you know your single-digit addition facts, right? Like you know that 8 plus 5 is 13, that's going to help you when it's time to do 80 plus 50, right? 80 plus 50. If 8 plus 5 is 13, 80 plus 50 is just 13 with a 0 attached to it, which makes the number 130. 130, because you got 8 10s and 5 10s instead of 8 1s and 5 1s. See, place value is critical. We got to understand that, right? So that's going to be 130 plus this 6 right here is 136. Oh, my marker's dying. Oh, no. So 136. All right, so I got 136. Yeah, let me get rid of this, Joe. You done. All right, so now 11 times 16, right? 11 times 16. Now 16 is the bigger number, right? So I'm gonna do a number bond with the 16. I'm gonna break the 16 down into 10 and 6, right? That's what I'm gonna do. Then I'm gonna do the distributive property. I'm gonna do 11 times 10 plus 6, because 10 plus 6 is equal to 16. Not 10 minus 6, not 10 divided by 6, not 10 times 6. 10 plus 6 is equivalent to 16. So that's why I'm replacing the 16 with 10 plus 6. Just like I replaced the 15 with 10 plus 5. I replaced the 17 with 10 plus 7, right? I replaced this 12 with 10 plus 2, because the expression has to be equivalent to the number that I'm dealing with. All right, so now I'm gonna distribute the 11 times 10. Now, if I know that 11 times 1 is 11, that means 11 times 10 is 110. 11 with a 0 attached to it, right? So that's gonna be 110. And then 11 times 6 is 66. That's a multiplication fact you gotta know, right? 11 times 1 up to 11 times 9, it just, you take the digits, you take the digit and double it. So 11 times 9, 99. 11 times 8, 88. 11 times 7, 77. And so on. And then we do 110 plus 66. So 110 plus 60 is 170. And then 170 plus 6 is 176. All right? So again, that's just a little, a little multiplication trick using the distributive property. I'm telling you, the distributive property is very helpful. It's very helpful. I can't stress it enough, right? And I'm really excited about the distributive property because I didn't really dig how much functionality it had, right? I like that word, functionality, right? I didn't realize how much functionality it had until in the last few years. I learned the distributive property like 30, 35 years ago, like when I was a youngin'. But I was very closed-minded in terms of like what I thought it was good for, right? I strictly limited, my use of it to like algebra equations or evaluating algebraic expressions, multiplying polynomials and all that, which is cool. You use it for that, but I ain't even dig how like, before you even get into the algebra with the variables, you can use it even just with multiplying regular numbers. I ain't even know, right? So yeah, so definitely, so if you're a parent watching this, make sure your children know about the distributive property. The distributive property is very important. It's a very important tool, right? It's not a punishment, it's a tool. It's meant to benefit you, meant to help you, meant to help them. All right, so go get some practice, make up some problems like this, or ask your teacher for some problems like this, your professor, whoever, whatever, wherever you at, whatever educational space you're in, get some practice. It's not enough to just watch the video. Watching the video is cool. Make sure you subscribe to the channel, but also get some practice, okay? Definitely get some practice. Look up Franz Fanon, read about him, get into his work, tell somebody else about him, all right? I'll see you in the next video. Peace.